In this session is the continuation of time domain behavior from pole zero plot. Here I'll be discussing about the stability of the network in relation to the location of the poles in the S-plane. In the earlier lecture, we saw about the time domain response with respect to the location of the poles in the S-plane. Now we are going to see the stability with respect to the location of the poles in the S-plane. These are the 5 properties of the stability of the network. Coming to the first one, when all the poles lie in the left half of the S-plane, the network is said to be stable. We can see the time domain response when the poles were on the left half of the S-plane. We can just see that. This is one case when the poles lie in the left half of the S-plane. We can see that it is an exponentially decreasing wave, that is, it is stable. The system is bounded and it is stable. Here is another case when the poles are on the left half of the S-plane. It is also decreasing, that it is coming to a stable state. This property, when the poles lie in the right half of the S-plane, the network is said to be unstable. In this case, we can see the pole is in the right half of the S-plane, that is the time domain. Time domain, we can see that it is exponentially increasing. It has no limit. It is going on increasing and increasing. That is, it is unstable. See, in this example also, it is a underdamped signal. It is going on increasing and increasing. That is, it is unstable when the poles are on the right half of the S-plane. When the poles lie on the j-omega axis, the network is said to be marginally stable. The poles lie on the j-omega axis. When there are multiple poles on the j-omega axis, the network is said to be unstable. When the poles move away from the j-omega axis towards the left half of the S-plane, the relative stability of the network improves. Here we can see that as the pole move away from the imaginary axis, it decays fast. That means it is becoming stable faster than the pole which is nearer to the imaginary axis. The response for the pole nearer to the imaginary axis, it decays faster. So therefore, this is more stable.